In 1960, the United States military launched a drone over the Soviet Union. It was a converted jet with a camera bolted to its belly. No weapons, no autonomy, no way to bring it home. It cost more than most houses and was designed to be thrown away after a single flight. 66 years later, in March 2026, the US military launched a different kind of drone over the Middle East. It was called Lucas. It cost $35,000, and it was a near-exact copy of an Iranian design, reverse-engineered, mass-produced, and sent back to strike the very forces that invented it. From a disposable camera with wings to an autonomous swarm that thinks faster than any pilot alive, this is the complete evolution of US military drones. Before drones existed, seeing the enemy required a human being inside an aircraft flying over hostile territory. Reconnaissance pilots in the Cold War flew alone, unarmed, at extreme altitude, hoping that speed and height would keep them alive long enough to bring the photographs home. Sometimes it worked. Sometimes it didn't. On May 1st, 1960, a Soviet SA-2 missile struck Francis Gary Powers' U-2 spy plane at 70,500 feet. He survived. The diplomatic fallout nearly triggered a nuclear war. And inside the Pentagon, a question that had been theoretical suddenly became urgent. What if the pilot didn't need to be in the aircraft at all? The answer had already been in development for 2 years. It was called the Ryan Model 147 Lightning Bug. A modified Firebee target drone, originally built to be shot at, retrofitted with reconnaissance cameras and launched from beneath the wing of a DC-130 mothership. It weighed just under 1,500 pounds. It had a wingspan of 13 feet, and it had no landing gear. Recovery meant deploying a parachute and hoping a helicopter could snag it mid-air. If the helicopter missed, the drone crashed. If the enemy shot it down, nobody died. That was the point. The Lightning Bug flew its first operational mission over China in 1964. Over the next decade, more than 3,400 missions followed. Over China, North Vietnam, and North Korea. The drones were primitive. They couldn't change course. They flew pre-programmed paths and returned with film canisters that had to be physically retrieved and developed. But they gathered intelligence from airspace so dangerous that no pilot would have survived it. 34 Lightning Bugs were shot down over North Vietnam in a single year. Not one American life was lost. But buried inside this crude beginning was a design principle so radical that the Pentagon almost dismissed it entirely. A principle that wouldn't fully mature for another 5 decades. And when it did, it would make a $35,000 drone more strategically valuable than a $100 million fighter jet. And there was something else. Something even the engineers at Ryan Aeronautical didn't fully grasp at the time. The Lightning Bug wasn't just a new kind of aircraft. It was a new kind of psychological weapon. Enemy air defense crews were forced to fire expensive missiles at cheap targets. Radar operators couldn't distinguish a Lightning Bug from a full-sized fighter until it was too late. The drone polluted the information environment, creating confusion, waste, and hesitation across the entire enemy defense network. That psychological dimension, the ability to impose cost and chaos without risking a single life, would take decades to be formally recognized as doctrine. But in 1964, over the jungles of Southeast Asia, it was already working. Exodus traces the complete evolution of the world's most powerful military technology. Every week. Subscribe now. The transformation ahead is the one nobody sees coming. By the early 1970s, the Lightning Bug program was classified and nearly forgotten. Vietnam was ending. Satellites were replacing aerial reconnaissance. And inside the US military, drones were considered a dead-end technology, too unreliable, too limited, too primitive to compete with crude aircraft. For almost 15 years, the United States effectively abandoned drone development. The engineers who had built the Lightning Bug scattered to other programs. The institutional knowledge accumulated across 3,400 combat missions evaporated. The most combat-tested drone program in history was boxed up and filed away in classified archives. It was Israel that changed everything. In 1982, during Operation Mole Cricket 19, the Israeli Air Force launched waves of small, cheap decoy drones over Lebanon's Bekaa Valley. Syria's air defense operators saw the radar contacts and fired. They launched nearly every surface-to-air missile they had at targets that cost a few $1,000s each. While the Syrians reloaded, Israeli jets swept in and destroyed 19 missile batteries in minutes. The entire Syrian air defense network in the Bekaa Valley was eliminated in a single afternoon. The drones never fired a shot. They didn't need to. They had done something no crewed aircraft could do. They had made the enemy waste his ammunition on ghosts. The Pentagon watched that operation and realized what it had missed. Drones weren't just about cameras. They were about cost asymmetry. A drone that costs 1% of the missile fired to kill it wins the exchange every single time, even if it's destroyed. That insight, cost as a weapon, was the principle the lightning bug had hinted at 2 decades earlier. The same principle the engineers at Ryan Aeronautical had seen, but couldn't articulate. And it was about to reshape everything. But the road from insight to implementation was neither straight nor fast. The Pentagon spent much of the 1980s debating whether drones belonged in the force structure at all. Fighter pilots dominated Air Force culture. To them, an unmanned aircraft wasn't just inferior. It was an insult. The idea that a machine could replace a trained aviator was treated with open contempt in Pentagon corridors. Drone programs were starved of funding, assigned to minor offices, and kept far from the mainstream of combat aviation planning. The technology was ready. The institution was not. What finally broke the resistance was not a strategic vision. It was a war. In 1991, during Operation Desert Storm, the U.S. military deployed the Pioneer drone, a small, Israeli-designed reconnaissance UAV launched from Navy battleships. The Pioneer was crewed even by 1990s standards. It had a range of 115 miles. It could stay airborne for about 5 hours. Its camera produced grainy black and white footage. But during the bombardment of Failaka Island, Iraqi soldiers saw a Pioneer circling overhead and did something that no military analyst had predicted. They surrendered to it. They waved white sheets and undershirts at a drone. It was the first recorded instance of human combatants surrendering to a machine. The psychological dimension that the lightning bug had hinted at in 1964 was now undeniable. Drones didn't just gather intelligence, they projected power. They changed behavior on the ground without firing a weapon. After Desert Storm, funding began to flow. And in 1994, the aircraft that would transform drone warfare forever took its first flight. The General Atomics MQ-1 Predator, 49 feet long, a wingspan of 55 feet, a Rotax 912 engine producing just 115 horsepower, less than a family sedan. Top speed, 135 miles per hour. It was slow, it was loud, it was fragile. A strong headwind could ground it. But it could stay airborne for over 24 hours, beam live video back to operators thousands of miles away via satellite link, and loiter over a target area for hours at a time, watching. Waiting. For the first time in history, a military commander could observe a battlefield in real time from the other side of the planet. The Predator didn't just see the enemy, it stared at him. For hours, without blinking. The Predator changed the timeline of warfare. Before the Predator, intelligence was something you gathered, brought back, analyzed, and acted on days later. After the Predator, intelligence was something you watched in real time on a screen in Nevada while drinking coffee. The sensor revolution had arrived, but the generals wanted more than eyes. They wanted teeth. On February 16, 2001, a Predator fired a Hellfire missile for the first time during a weapons test at Nellis Air Force Base. The drone that had been built purely to watch was now a killer. After September 11th, the armed Predator deployed to Afghanistan. Its first confirmed strike came on October 7, 2001, the opening night of Operation Enduring Freedom. A single Hellfire, launched from a drone flying at 15,000 feet, piloted by an operator sitting in a trailer in the Nevada desert. The target was over 7,000 miles away. The operator drove home for dinner that evening. That moment, a weapon fired in Afghanistan by a pilot sitting in Nevada, represented a rupture in the history of warfare as fundamental as the invention of gunpowder. For the first time, the act of killing in combat was completely separated from physical risk to the killer. The implications were staggering, and the debate over what that separation meant, morally, legally, strategically, has not been resolved to this day. Within 5 years, the Predator had become the most feared weapon in the war on terror. Between 2004 and 2015, CIA and US military Predators conducted an estimated 540 drone strikes in Pakistan alone. Thousands more followed across Yemen, Somalia, and the tribal regions of Afghanistan. The Predator reshaped the geography of warfare. Targets that would have required special operations teams, airstrikes, or ground invasions could now be eliminated by a single operator watching a screen. But it had a critical vulnerability. one that its creators knew about from the beginning and could not fix. At 135 miles per hour, the Predator was slower than most civilian propeller aircraft. Any nation with a functioning air force could shoot it down with ease. In contested airspace, against China, against Russia, against any modern military, the Predator was a sitting duck. The solution was already under construction, and it would become the most dominant drone in history. Drop a comment. Which era of this evolution hit the hardest? The disposable spy drones of the Cold War, or the hunter-killers of the War on Terror? The MQ-9 Reaper, 66 feet long, a wingspan of 66 feet, a 950 horsepower Honeywell turboprop engine, maximum speed, 300 miles per hour, endurance, 27 hours, payload capacity, 3,800 pounds, enough to carry 4 Hellfire missiles, 2 500-pound laser-guided bombs, and a full sensor suite simultaneously. The Reaper wasn't a surveillance aircraft that happened to carry weapons. It was a hunter-killer built from the ground up to find, track, and destroy targets autonomously for over a full day without landing. The Reaper's sensor ball, the multi-spectral targeting system, could read a license plate from 2 miles above the ground. Its synthetic aperture radar could map terrain through clouds, dust storms, and total darkness, and its Lynx radar system could detect a human-sized target walking across open ground from over 15 miles away. The Reaper didn't just watch. It hunted. Between 2007 and 2020, MQ-9 Reapers flew more than 2 million flight hours. They conducted strikes in Afghanistan, Iraq, Syria, Yemen, Libya, and Somalia. A single Reaper could orbit over a city for an entire day, surveilling dozens of targets, while its operators rotated through shifts 8,000 miles away. The aircraft cost roughly $32 million per unit, a fraction of a crewed fighter. Its operational cost per flight hour was approximately $4,500, compared to roughly $68,000 per hour for an F-35. On January 3, 2020, an MQ-9 Reaper fired the Hellfire missile that killed Iranian General Qasem Soleimani near Baghdad International Airport. The strike demonstrated the Reaper's precision. A single vehicle targeted in a convoy on a public road, in a foreign capital, authorized at the highest level of government. Whether that strike was wise remains debated. That it was technically flawless is not. But the Reaper had inherited the Predator's fundamental limitation. It was built for uncontested airspace, environments where the enemy had no radar, no jets, no modern surface-to-air missiles. In the skies over Afghanistan, the Reaper was untouchable. Against China's integrated air defense network, or Russia's S-400 batteries, the Reaper would be detected, tracked, and killed within minutes of entering the battlespace. And by 2020, it was becoming clear that the next war would not be fought in uncontested skies. The era of the Reaper was ending. The era of expendability was about to return. And the spark came from the most unlikely source imaginable. In September 2019, a swarm of low-cost drones and cruise missiles struck the Abqaiq oil processing facility in Saudi Arabia. The attack knocked out roughly 5% of global oil supply overnight. The drones used in the strike were variants of the Iranian Shahed 136, a simple delta-wing, one-way attack drone powered by a small piston engine. Each unit cost an estimated $20,000. The air defense systems protecting Abqaiq, Patriot batteries worth over $1 billion, failed to intercept them. The world's most expensive shield had been penetrated by some of the cheapest weapons ever built. The Pentagon took notice. So did every military on the planet. The Shahed 136 was crude by American standards. GPS guided. No real-time communication. No ability to retarget in flight. But it proved something that the lightning bug had first demonstrated 60 years earlier. That a cheap drone you expect to lose can be more effective than an expensive one you cannot afford to lose. Cost asymmetry. The same principle. Scaled up to strategic impact. Then came Ukraine, and the lesson became impossible to ignore. When Russia invaded Ukraine in February 2022, both sides deployed drones at a scale never seen in modern warfare. Ukraine used Turkish-made Bayraktar TB2 drones to destroy Russian armored columns in the opening weeks. Russia responded with Iranian-supplied Shahed 136 drones to strike Ukrainian power infrastructure. But it was the smallest drones, commercial quadcopters costing a few $100s, modified to drop grenades, that revealed the true future of warfare. Ukrainian soldiers were destroying million-dollar Russian tanks with drones bought on Amazon. The cost ratio was not 10 to 1, it was 10,000 to 1. By 2023, Ukraine was losing an estimated 10,000 drones per month. Russia was losing similar numbers. Drones had become the most consumed munition of the war, more expendable than bullets in some sectors of the front. The transformation that began with the lightning bug in 1964 had reached its logical conclusion. Drones were no longer aircraft. They were ammunition. Hundreds of thousands of viewers watch Exodus every week. If this evolution is resonating, subscribe. The transformation is just getting started. What happened next stunned even the most seasoned defense analysts. The United States didn't just study the Shahed 136, it reverse-engineered it. In 2024, the Defense Innovation Unit awarded contracts to build an American equivalent, a low-cost, expendable, one-way attack drone that could be manufactured in the thousands and deployed at a fraction of the cost of traditional munitions. The program was called Lucas, Low-Cost Unmanned Aerial System. The target price, under $40,000 per unit. Lucas was designed with one overriding philosophy. Good enough is perfect. It didn't need stealth, it didn't need advanced sensors, it didn't need to survive. It needed to fly to a set of coordinates, deliver a warhead, and cost less than the missile that would be fired to intercept it. Every dollar spent shooting down a Lucas drone was a dollar the enemy couldn't spend on something else. The weapon's destruction was part of its value. In March 2026, Operation Epic Fury became the first known combat deployment of Lucas drones by the U.S. military. The details remain partially classified, but the operational concept was clear. Waves of small, GPS-guided, expendable drones launched from mobile ground platforms and naval vessels, designed to overwhelm enemy air defenses through sheer volume. Each Lucas drone cost roughly $35,000. A single interceptor missile fired to shoot one down cost anywhere from $500,000 to $3 million. Every interception was a financial victory for the attacker. The math was devastating. America had copied the architecture of an Iranian drone, then used American manufacturing precision to make it more reliable, more accurate, and more producible at scale. Then deployed it in combat against the very forces that had pioneered the concept. The irony was not lost on anyone, but Lucas was only the beginning. The drone landscape in 2026 is evolving faster than any weapons category in modern history. The U.S. military now operates across the full drone spectrum, from the $35,000 Lucas to the $200 million RQ-180, a classified stealth reconnaissance drone believed to operate at altitudes above 60,000 feet with radar cross-sections smaller than a marble. Between those extremes sits an entire ecosystem of unmanned systems reshaping every branch of the military. The MQ-25 Stingray, the Navy's first carrier-based drone, not a fighter, not a bomber, a tanker. 76 feet long with a payload capacity of 15,000 pounds of fuel. Its mission, extend the range of carrier-based F/A-18S and F-35CS by refueling them in mid-flight, keeping human pilots far from the reach of Chinese anti-ship missiles. The Stingray doesn't fight. It keeps fighters alive. First deployment, 2026. The XQ-67A Offboard Sensing Station, a stealthy jet-powered drone designed to fly ahead of crewed fighters into the most dangerous airspace, acting as a sensor and decoy. Expendable by design, built by General Atomics under the Air Force's Collaborative Combat Aircraft Program. Unit cost target, under $20 million, roughly 1/7 the cost of an F-35. The Air Force plans to field at least 1,000 of them by the early 2030s. If you've made it this far, you understand why evolution matters. Subscribe to Exodus. This is where the future becomes visible. The Collaborative Combat Aircraft Program, known inside the Pentagon as CCA, represents the most radical shift in air combat doctrine since the introduction of stealth. The concept is straightforward. Every crewed fighter jet will fly into combat alongside 2 to 5 autonomous wingmen. These drone wingmen will carry sensors, weapons, and electronic warfare systems. They will fly formation, execute tactics, and engage threats, all without a human pilot. The crewed aircraft becomes a quarterback, commanding a team of machines. Lockheed Martin, Boeing, Anduril, and General Atomics are all building CCA prototypes. First operational capability is projected for 2028. By 2030, the Air Force envisions mixed formations of F-35s and autonomous wingmen as standard operating procedure. The pilots will still be there, but they will be commanders, not lone warriors, and the ratio of machines to humans will only grow. Save this video. This is the kind of documentary you come back to when the next generation of drones makes headlines. By 2035, current projections suggest the U.S. military will operate more unmanned combat aircraft than crewed ones. The tipping point is not about technology, The technology already exists. It is about trust. Commanders must trust autonomous systems to make targeting decisions in environments where communication with human operators is jammed, degraded, or impossible. The question is no longer, can a drone fight on its own? The question is, should it? DARPA's Air Combat Evolution Program, ACE, has already demonstrated AI pilots defeating experienced human fighter pilots in simulated dogfights. Not once, repeatedly. The AI systems react faster, pull more G-forces, and never panic. In controlled tests, AI-flown F-16s have outperformed human-flown F-16s in within-visual range combat scenarios, with a consistency that left test pilots shaken. In September 2023, an AI-controlled F-16 flew with a human safety pilot on board in a real aircraft, not a simulation, executing combat maneuvers at speeds and G-loads that pushed the airframe to its limits. The machines are not just catching up. In narrow tactical domains, they have already surpassed their creators. By 2040, the vision inside the Pentagon's classified planning offices is a force structure dominated by unmanned systems at every level. Autonomous submarine drones patrolling the Pacific, programs like the Orca XLUUV, a Boeing-built unmanned submarine over 85 feet long capable of deploying mines, launching torpedoes, and conducting surveillance missions lasting months without surfacing. Drone swarms numbering in the hundreds launched from a single cargo aircraft. Ground-based robotic combat vehicles clearing urban terrain ahead of human soldiers. And in the air, formations of stealth drones coordinating attacks across hundreds of miles without a single human command, using AI-driven decision engines that process sensor data, identify threats, assign weapons, and execute strikes in the time it takes a human pilot to blink. But the ultimate destination may be something even more transformative. By 2050, Pentagon futurists and DARPA program managers describe a concept they call Mosaic Warfare, a battlefield composed entirely of small, cheap, interchangeable autonomous units that self-organize into combat formations the way a mosaic assembles into a picture. No unit is critical. No loss is catastrophic. Destroy one, and the swarm reorganizes. Destroy 100, and the swarm still functions. The individual drone is worthless. The network is invincible. The evolution comes full circle, from the disposable lightning bug of 1964 to a disposable swarm in 2050. The principle never changed, only the scale. The complete story of American military drones stretches from a modified target drone launched under the wing of a cargo plane in 1964 to a self-organizing swarm of autonomous weapons that may never need a human command. From the lightning bug to Lucas. From a camera with wings to an intelligence that thinks faster than the pilots it was built to replace. In 1960, removing the pilot from the aircraft was a way to avoid losing a life. By 2050, removing the pilot may be the only way to win. Not because humans are unwilling to fight, but because the battle will move too fast for any human mind to follow. The first drone cost more than a house and flew one mission. The drones of 2050 may cost less than a car and fly forever. That transformation, from expendable curiosity to the dominant force in modern warfare, didn't happen in a single breakthrough. It happened across 60 years of failure, reinvention, and a single principle rediscovered again and again. The weapon you can afford to lose will always outlast the one you cannot. Next week on Exodus, the complete evolution of the aircraft carrier, from wooden flight decks on converted cruisers to the 4.5-acre nuclear-powered cities that project power across every ocean on Earth. That is one you do not want to miss. Subscribe to Exodus, so it's waiting for you. The first drone was a camera with wings. Disposable, unreliable, forgotten for decades. By 2050, swarms of autonomous aircraft may patrol entire continents without a single human command. From a converted jet over the Soviet Union to machines that think for themselves, the evolution of the drone didn't just change aircraft. It changed the definition of war itself. This is Exodus, how everything transforms.